Right, so here we go. So this is the first question. Now, as I said to you before, we will do part B. It's better to do part B than part A. And the reason for that is simply because there's two ways to do it. Multiply. Multiply is a bit more difficult way to do it. The easiest way, we've got to do part B anyway. You won't find me saying this many times, but this is the one time I make an exception. You do this part before you do that. And when I do the maths, you'll see why it's easy. So first of all, part B, because part A, I don't put anything there. You see my point? There'll be a gap where you can put the data. So first of all, it says use data from experiment number 1, there's number 1, to calculate K and state its units. And that's the complete roll. So you've got the rate equation up there. We need to rearrange that, get K the subject, which I will oblige. So there we go, K is equal to rate. All this is dividing, so multiplying, so it will divide. So the rate for experiment 1, 1.8 times 10 to the negative 3, and the concentration of P is 0.20. We need to square that, and you times that by the concentration of Q, which is 0.30. So let's pick up the calculator. So, fraction key 1.8 exp minus 3. Can you also do the number crunching yet? Just double check. My answer agrees. And then we square that, and then we times that by 0.30. And I've got 0.15 on the calculator. Yeah? So it's 0.15. Now the units of K you already had practice earlier on, so we'll just go in the corner, mole dm to the minus 3. You can pitch that, look, if you've forgotten it, it's still in the table, that's what I meant. Over this, which will be mole cubed, because it's 3 power, yeah? And once again, if you are having an issue with this, you can always do that, don't worry about that. So, and then dm to the negative 9, this cancels out with that, that cancels out. So at the top we've got seconds to the minus 1, at the bottom mole. 3 take away 1 is 2 power and dm minus 6. Make sense? So what we have is mole to the minus 2, dm to the 6 seconds to the minus 1. Happy? And then we can slot that here because 1 mark is for the units. Happy? Okay, now the next thing is part, I can use that now to do part A. So if you think about it logically, I'll just go on this side of the board. So this value here, if you think about it very quickly, rate, we know what the rate constant is, 0.15. The P, the concentration of P is 0.40. We've got to square that and we times it by the concentration of Q. Is that all happy? And then we can work that out. That's why the gap is there. You'll find in the exam they'll give you a lot of lines. So again, double check this. I'm doing this right. 0.40 squared times 0.6, and we get 0.0144. So I'll just slot that in there. I don't need to put it in standard form. It doesn't tell me to do so. So that's my decision. The next one is this value here. We've got to get the concentration of Q, so all I do is rearrange that. That's fairly easy. I would rearrange it first. So Q is rate divided by the K times the concentration of P squared. So the rate for experiment 3 is 5.4 times 10 to the minus 3. K is 0.15, which we worked out earlier on for part B. And P is given as 0.6. Yes, are you happy? There it is, 0.6. And we have to square that. So check this one out, double check. So 5.4 exp minus 3, joystick down, 0.15 times 0.6 squared. And we end up with 0.1. Now what I might even do is put it to, another significant figure like that. Happy? And then finally we've got experiment number 4, P missing. So if we rearrange that for P, So P squared is rate, and those two will divide K over Q. You happy with that? And therefore P is equal to the square root of rate divided by K times the concentration of Q. So it's the square root of the rate. For experiment 4, there it is, it's 12.2 times 10 to the minus 3 divided by K 0.15, and the value of Q for experiment number 4 is 0.90, and let's do that. So square root 12.2 exp minus 3 0.15 times 0.90, and what have I got? So I got 0.30. Happy?
Yeah.
That's what you get on the screen, and that goes nicely in that gap. So that's what I mean. Do you now understand? So it's not often I say that. As I said to you before, there is a multiplier. I am not going to do the multiplier because, well, from my experience, a lot of students struggled with that. Okay? So this is better because you've got to work out that anyway. So already we've got 6 marks, and that is the last part now, is part C. So it says calculate the initial rate of initial rate using data from experiment 1 if both the concentration of P and Q is halved. So it ain't going to be that rate, is it then, if you're going to halve it? So what we do, we put the rate equation again, which was given in the question as K, concentration of P squared, concentration of Q. So K, will that remain that? 0.15? Yes, because if you look at my theory, I said in the theory, the rate constant is only temperature dependent, and I clearly said concentration has no effect. Yes? So that's not going to change. The P is, where is it? 0.20. We halved it times, and the Q will be 0.30 divided by 2. You happy with that? Because the question says we've halved those concentrations. So we do, sorry, I forgot to square that. Yeah, don't forget that. So it's 0.15 times 0.10 squared times 0.15. And that is 2.25 times 10 to the negative 4. And the units of rate are there. They won't give you any mark for the unit because it's just the numerical value. Yes? So that covers that as well, we've done.